Okay, so how was lecture last time? Do you have any problem with the last lecture?
We go through the tutorial as well.
We will today there would be no lab, so instead of lab we'll be having tutorials.
The review question one that you get.
Sorry?
What tutorial? The one you gave us last time.
Yeah. No, not that tutorial. That was just I want you guys to go through so that you can solve it. But today I will be solving some other tutorials with respect to Fourier transforms. So even the one you have now, you will get to know why I've given you, because there are so many exercises about derivation integration. So okay, so last time it was more or less like an introduction which we covered, and we also came to know that how we're going to find the RMS and how to find the average value. Today we are going to start a new topic, which is somehow how we're going to write a signal if you are given a complex signal and we are asked to write it in a simplified form. So how are we going to represent that? And later on you will see that in last lecture I told you that sine wave is a kind of Legos. You can write any signal in terms of sine signals. So this starting point of the lecture will be a bridge to the next one. So here as you can see that is written that if you have a complex signal, so the main aim is to find a simplified signal. So we will start with two simplification. One is called polynomial fit, which is quadratic or cubic fit, and then there will be a second one which is called mean square error. Let's start with the very first one. So here is you can see that we have this equation y equals to 1 plus 2x plus x squared plus 3x cubed up to x power 6. This means that here you can see that the variable has 6 powers. So it means that it is degree 6 equation. So looking at this equation, this is a complex equation. And if you have a look on the, if we plot this equation, so we put different values of x, so starting from 0, 0.2, 0.4, you will see that you will get this blue curve. However, doing processing on this equation is hard because you have so many terms and especially you are going up to 6th order. So the objective here is to simplify this equation into a simpler equation. So here this equation has been simplified into 1 plus 8x squared, and you can see that the black curve is for the new equation. They are closely following each other. So it means that we can simplify a complex equation into a simpler equation, little bit compromising on the accuracy, but it will solve many other problems. So more or less you can see that it is following curve. So how are we going to achieve, how are we going to get this equation? Here you can see that it's written quadratic fit, and I guess everyone know what is the basic equation for a quadratic. So it's a naught plus a1x plus a2x squared. Quadratic means power 2. So it means that this is the equation that we want to achieve for this one. So how are we going to proceed with this? In order to proceed with this, in this equation you can see that we have a0, a1 and a2, they are unknown. So we need to somehow find them. But how to find them? Using the original function. So what we're going to do, we're going to take 3 points from the original function. So you can see that 3 points have been taken, 0, 1, 2. So looking at this curve, so you have taken 0, you have taken 1, you have taken 2. You can take, for example, 0.4, you can take 1.4, it doesn't matter. So you can take whatever points you want. So here we start with 0, 1 and 2. So for these 3 values, we will going to get the value of y from this equation. So it means that how we started with writing a quadratic equation, then we moved on selecting 3 points from the complex signal, from the complex equation. And after selecting 3 points on x-axis, we're going to find the value from the y-axis. So if I put 0 in this equation, you will get some value. Then if you're going to put 1, going to put 2, and so on. So moving further, if you put x equals to 0, it means that in this equation, we're going to put x equals to 0, so you will get y equals to 1. So it means that now for x equals to 0, you can say that a naught equals to 1, because you are taking x and then you are taking the y value. So here these values are already taken, so I have put 0, 1, 2 in this equation, and I know that the corresponding values for 0 is 1, for 1 is nearly 9, and for 2 is 33. So these 3 points I already know. Now going to starting putting these points in the quadratic equation. So the first point is x equals to 0. So I put 0, 0, so remaining is a naught. And I know at this point the value of y is 1 from this table which I have obtained from the original function. Then second point, x equals to 1. So when I'm going to put x equals to 1, so you can see that it would be a naught plus a1 plus a2, because here is 1, here is 1. Square of 1 is 1. And the value of y at this point from the original function was how much? Was 9. Then finally you're going to put x equals to 2. The value for x equals to 2 from the original function, you could simply put 2 here, and you will see that you will get value 33. 33 equals to a naught plus, here you have 2 a1 plus 2 squares, 2 power 2 is 4. So you get 4a2. So it means that now we have 3 equations, we have 3 unknowns. So you have a naught, you have a1, you have a2. So we have 3 equations, 3 unknowns. So we can easily solve them. We can directly take a naught equals to 1, which is easy from this equation. So you can see that a naught equals to 1, and rest, if you solve them, you can put a naught here. You know, this is basic math, and you can simply simultaneously solve these equations, and you will get your a naught, a1 and a2 equals to 1, 0, 8. It means that using the complex equation, the quadratic constant that you have found is 1, 0 and 8. It means that here you will have 1 and here you will have 8. So 1 plus 8 x squared. So you can see that 1 plus 8 x squared. And
you know the 3 coordinates, where is it from? Is that from the original, like, 6?
yeah, these coordinates are these.
These ones, yeah.
These ones.
Yeah.
These ones are from the original equation.
Okay.
So what you're going to do, because you are actually simplifying this equation for a certain portion. So the very first thing is that you're going to select the period in x side, that how much portion you want to simplify your equation. Then from that portion you're going to select 3 points. So the best is that you select these points from equal distance. So 0, 1, 2. You can select points intermediate. We will see later on that it will change the curve of approximated equation somehow. But these points will be taken from the original equation. Either you can take them from the graph if given. If not, you will be given, for example, that x is between 0 and 2. Then you select, okay, 0, then 1, and then 2. Then these x values, you're going to put it in this original equation, and finally you get 3 points. Okay, so here you can see that the equation that we have achieved is of very low order. It's second degree, because degree of the variable is 2. From 6 we came to 2, and still you can see that the approximation is somehow close. So what do you think that if we, because at the moment we have approximated it with square, so this is the accuracy. So if I increase the order of the equation, for example, if I go to x power 3, whether the accuracy would be good or bad. At the moment you can see that this 6th order is approximated with 2nd order. So what if I go to 3rd order? I add another term here, which is a3x cubed. So whether the accuracy will go up or down?
Down.
Why?
Because you are increasing the orders. There will be some.
Your original equation is of 6th order, right?
Yeah.
And you are reducing it to 2nd order. It means that you are compromising a lot. If, for example, I am reducing it to 3rd order, the accuracy should go slightly. The accuracy should be improved a little bit, because this is 6th order. So you are taking out 3 terms and you are approximating it with more number of terms. Here it's only 2. Here it's 3. So overall, roughly we can say that increasing the order of equation will improve the accuracy, because now you have one more term to represent your function. So it means that you are adding more degree of freedom into your equation. You have more control. Any question on this? So you understood taking 3 points, putting those points into quadratic equation, getting 3 simultaneous equations, and then solving them. Now this brings me to cubic fit, which is no difference than the previous equation. The only thing is that here we have added another term. So we have a naught plus a1x. Yes.
So when you add another term, do you have to add another point?
Yes, we have to add another point. Very good. Because we need to find 4 constants now. So it means that we need 4 equations. So we have to take a fourth
And you
point.
can
as well.
choose it. You can choose it like
From anywhere. Yes, you're right. So here you can see that you have now 4 constants that you have to find. And as he rightly said that we need 4 points. Mean we need 4 equations. So here you can see that again we have 0, 1, 1, 9 and 2, 3. 2 to 33 are the same points which was taken previously. This is a new point which was roughly taken from 1.6. And before going into more detail, you can see here this is the main equation which is in blue, which was the original function, and this is the approximated function which is cubic fit. So you can see that the cubic fit here it is following closely. Why? Because somehow we cannot generalize, but somehow the point was taken from here. But you can see that there was a big gap here. So you have point at 0, then you have point at 1, and then you have 2 points. From this point onwards you have 2 points. But here you have only 1 point. So you can see that here your function is a bit deviated from your original function. So that's why I said that of course the accuracy will go higher by increasing the order of the equation, but it also depends on selection of the point. So that's why I said it is good that if you select point at equal distance. So if you were supposed to select, for example, 4 points, so divide this 2 with 4, and then you can take, for example, 0.5, 1, 1.5 and 2, and this will improve your accuracy, and which we can see from here clearly that 1.6 was taken from here. So here you have close following, but on the other hand the place where you have there was no point in between these two, so you can see that the accuracy went slightly low. Why? You have deviation from this. So this kind of approximation is called curve fitting. So it means that we are taking one equation, or indirectly from equation we can see we have a curve, then we are substituting points, and then we are fitting that original curve. So trying to go close to the curve. But the problem is that these methods are very basic. Like I said, that a small mistake in choosing point could lead to bigger errors. So that's why we in engineering or in signal processing we go for more complicated method. Any question on the previous side? Okay. So now moving further towards approximation of complicated signal by minimization of mean square error. So this method is rather bit smarter than the previous method. And this will take us close to Fourier series, which is our main aim, where we are heading that every signal can be represented by a combination of sine signals. So what happens in this case that we are saying we have a complicated signal which is f1 of t, and we want to approximate it with f2 of t. In previous case, we all know that we selected points and then we move towards taking the original equations, for example for quadratic fit, for cubic fit. But here we are saying that the complex function is equal to the original function with a multiple r naught. So at the moment we don't know r naught. For example, that if your f1 was 4 and if we selected f2 as 2, so we can say that f1 equals to 2 times f2. True, because f2 is 2. So if you multiply this 2 with another term 2, so it will give me 4. This is very basic example. So same holds here. So we can say that f1 equals to r naught times f2. So it means that here, who will be responsible for the accuracy? This r naught, right? If, for example, here I selected this r naught as 1, so this will result as 2. So it means it is not approximating function accurately. So it means that here the whole thing lies in r naught. So it means that we have to find r naught using some method, and we'll see how. So to find r naught is, you can see in the title we have said mean square error. So it means that we will be taking help from mean square error. So it means that we will see that what is mean square error. We have seen in the previous, I'm not sure if you have seen in the previous class, but mean square error is that you take the error between the actual function and the approximated function. So how much error should be? Ideally the error should be 0, right? So we want that the approximated function should be equal to the original function. So the very first step here is to take the error. So you can see that we have taken the error, which is f1 is the original function, r naught times f2 is the approximated. So f2 is the original function, and this is your approximation. So the very first step is done. So it means that we have our error. So now the next step is that you're going to square it, because you have error, then you have to square it, and then you have to take mean. So the second step was that we have squared it, and then the last step is that we have taken mean for it. So you can see that one by time we have studied the formula for average, that how you're going to average something. You take the function, you integrate it, and you divide it with the whole time period. So you can see that here your function was square. So you can see that you put the square function and then you have integrated it. So it means that we have achieved mean square error, starting from the original function, then the approximation, then we move towards finding the error, and once the error was found, we took square and sum it, and then divided by time, mean we have taken the average, or we have taken the mean. So it means that this equation is mean square error. So it means that if I have a look on this equation, it means that I'm going to find at every point, at this point I'm going to find error, square it, add, and keep on doing it along the whole curve. It means that I'm doing it for the whole curve, just taking the error then and adding it. Now the point is that we want this error to be minimum. So at the moment we have this equation. So how are we going to get this error as minimum? So normally we say that if we see the value of error with respect to this R naught. Why? Because only R naught is responsible for this reducing the error, because only R naught would decide what is the output. So that's why we are looking at error, we are looking at rate of change in error with respect to R naught. So it means that how R naught would be varied and how it will impact error. So it means that we want to see that when the rate of change of error with respect to R naught is 0, it means that the maximum error is reduced. There is no further reduction in the error. So that's why normally to find the minimum error, or to find the minimum, we normally look at the rate of change. So if, for example, we see that, okay, the error started from this point. So if this is your error, this error started from this point, and if this is R naught, for example. Error started from this one value, for example, and at this point it reached to 0.2, and after this it is not changing. So it means that after this point there would be no rate of change, there would be no further changes in the error. So that's why we need to take derivative of error with respect to R naught, because only R naught is responsible for all this. Okay, so now moving further, it means that we have mean square error calculated in the previous step, and we just need to take the derivative. How are we going to take the derivative? Okay, so we have written error. So it's d by dr naught. Okay, so it means that we have this error equation from the previous slide. So you can see that this is our error equation. We just need to take its derivative. So we have put this error in this equation. So this was the first step. Now the next step is to find the error. As I said previously that whenever we want to find integration or derivation, the very first step is to remove whatever which is unnecessary. So here you can see that this f1 of t is not the function of r naught. This is function of time, right? Whereas we are taking derivative with respect to r naught. In this case, in the second case, you can see that this r naught is the function of the variable with respect to which we are integrating. But you have also square here. So if for example I have this 2 plus x square and we want to take derivative. What is derivative for this?
2x.
How we find the derivative for square terms? So this 2 will come on the back side,
Yeah.
right?
The
Then
point
this
is,
thing would be written as 2 plus x,
and the derivative.
2
of
minus 1,
the
right?
derivative
And
of
then the
that.
derivative of inside thing. So if I write it here, so it means that
Chain
if
rule.
I want to find d by dx of 2 plus x, so it would be 2. So the very first rule is that this power comes on the back, 2 times 2 plus x, and this power would be subtracted by 1, and then you need to take again derivative of this thing. So finally it's 2 into 2 plus x, and for derivative of 2 is 0, and this would turn out as 1, right? So the same thing we're going to do here. So here you can see that although f1 of t is not function of time, not function of r naught, but there is something which is function of r naught, and we have square. So the very first thing you just okay. So here you can see that we have taken square on the back. Then we have written the same f1 of t, r naught, f2 of t, same as we have written 2 plus x. And then finally we have taken derivative of inside again. So derivative of this with respect to r naught would become 0, whereas derivative of this term with respect to r naught, this will come on the back and r naught would becomes 1. So that's why we have minus f2t. Any question on this? It's simple derivative, right? So we just take 2 on the back side, and then in the next step we take derivative of what is inside. So derivative of first term would be 0. The derivative of second term, here f2 is constant, r naught is function. So derivative of r naught would be 1, and it comes out as minus f2. Finally, why we are doing this? We are trying to find r naught. Our main objective is to find r naught, and everything is equal to 0. So finally, if you're going to rearrange this equation, you will get r naught like this. So r naught equals to find r naught, you need to know f1, you need to know f2, and then you have integrated between the period. As I said, that approximation is always done between two boundaries, like t1 and t2. And then in the denominator, you need to take square of f2, and then from t1 and t2. I will do an example, and then it would be more clear. So in this overall, we have not done much. We have taken one function, then we have taken another function which was r naught times the original function, and then finally we have taken mean square error and then integrated it with respect to r naught. Why? Because we wanted minimum error with respect to r naught. It means that we wanted to find a value of r naught for which we achieve minimum error. Okay, so let's take an example. So here the aim is to approximate complicated signal f1 of t with a simpler signal f2 of t in the interval 0 to 1. It means that we have our t1 here is this, and t2 is this. So it means that we have to approximate in this limit. So the complicated function is given as e power t minus 1, exponential of t minus 1, and the f of 2, f of 2, you can select anything here, or maybe sometime it is given that you need to select this specific f2. So here the f2 is simple linear function, which is simple a time t. So as I said that in this case you don't need to do all those steps. The only thing is you need to find R naught, because the things in the previous step was just derivations. So here we need to find R naught. You have f1 of t, you have f2 of t. So it means that the integration of the denominator is not a problem. We can easily do that, because in the denominator I know it's t square dt. So it would be, what is the integration of this? T square dt? No, integration, not derivative.
3t over 3.
So it would be as 2 plus 1 divided by 2 plus 1. It means that it's t cubed by 3. Or if I say if you have t power n, so it would be t n plus 1 divided by n plus 1. So this is the integration of with t n. Okay. Now the second thing is, here we need to find integration, but as you can see that you have two time functions which are multiplying with each other. So it means that here we going to use integration by parts. Who know how to find integration by parts? Integration by parts is if you have u function and you have v function, and you have to find, so you have to select a first function and a second function. You can do it. So first function into integration of second, whatever is the variable, you need to write dt or dx, then minus first function derivative, so it means that if you have two functions, you're going to select first function and second function, then first function will go as it, and you need to take integration of second function. Then in here you have two integrals. You can solve this integral first, but to solve this integral you have to first take the derivative. So it means that you have to take derivative of u, first function, and then this integration, and then finally you have another integration. So if we apply the same thing, can you please apply the same thing on this and see if you get the similar result like here? Can you apply integration by parts on this? You have to get your hands on these integrations, because you will be having a lot of mathematics afterwards. Can you quickly solve this integration with this method? And here I can tell you that you have to select u as your first function and this is your v. And then I will tell why I have selected u t as my first function. Hope it's done, right? You always select first function the function whose derivative is easy. Because later you can see that the function you have selected first, you have to take a derivative of that function. So always select a function whose derivative comes out as 1 or which is easy. So that's why here you can see that t is selected as first function, then integration of second, then minus derivative of first and integration of second. So t, and if I take integration of e power t, it would remain as e power t, there is no difference, minus derivative of t dash is 1, and I have taken this integration, which is e power t, and then finally you have to take this integration again, and which is e power t. So that's why you can see that you have t e power t minus e power t. So it means that we have solved this integration. Any question on this? Okay, so it means that the next step is to apply limits, because this integration is bounded between these two limits. So it means that on this function we have to apply limit from 0 to 1. So if we apply limit on this, what value do you get? So it means that now this R naught is equals to t e power t minus e power t, and in the denominator you have divided by 3, and this is from 0 to 1. So you know how to apply limits, right? Upper limit minus lower limit. So it means that on both functions, if this is your functions, you have to apply upper limit. So it means that if I apply upper limit, so it would be 1 e power 1 minus
0.
Yes, you're right. We can take both functions separately and apply limits, or we can take it as a single function, which is I'm doing now. So e power 1, this is your first upper limit on this, and now minus lower limit, which is 0. Which is 0 for this, because when you will be multiplying 0 times e power 0, so it will become 0, and then the lower thing is e power 0. So So if you apply these limits, you will finally get that your answer is 1.5. So it means that now what is my output signal? My output signal is f1 of t equals to r naught times f2 of t, and f2 of t is t and r naught is 1.5. So it means that here we have approximated that function with 1.5 t. So it means that f1 was e power t minus 1, which was an exponential function, and we have approximated it with a linear function, which is just 1.5 times t. And here it said that 1.5 t is the best fit. Why best fit? Because we have, based on the formula r naught, which comes from the derivative of error with respect to r naught, it means that this is the best value of r naught that we can get. There is no other value that can achieve better fit than this. And if we plot this equation, you will see that this green is 1.5 t and this is your original function, although they are away from each other. Why? Because e power t is approximated with a linear function, which is a very loose approximation. This can be improved by taking a better f2 of t. So we can achieve better f2 of t. Okay. So it means that, but technically, if we go into technical detail, this method looks more promising and is more technical rather than the curve fitting method. Because here we have found value based on mathematical equations, and we are taking derivative, which is more solid way to find something. In the previous case, you need to choose different points, which somehow is hit and trial method. Okay, so it means that we can further improve our approximation by approximating the function with multiple functions. Previously, we were approximating it with R naught F2. So it means that we were saying that F1 is complicated function. We are approximating it with taking F2 and then we are multiplying R naught. But here you can see that we are approximating the same function F1 with F2, F3, F4, Fn. It means that we can improve the accuracy of approximation accuracy by taking multiple terms. And from here, I'm somehow trying to link towards the Fourier series. So, but so it means that I have a function and I can write it with multiple functions. It means that the known function, I want to break down it with different functions. That means that I'm trying to see, indirectly I can say that I'm trying to filter, I'm trying to see what is inside that signal. By approximation, this is one way of coming, that it is an approximation. The other side is that I want to break the known function to see what are different components inside it. For example, if I'm making a cake, I need to see what are inside. So I need to break the cake and see what is inside. So the same goes here, that if you have function f1 of t, I want to see what are different components which have created this signal. And what is physical interpretation for this? Physical interpretation is that if you have many signals, for example, if you have signal coming in, you want to see that whether it has noise, whether it was a voice signal, what are different frequencies and so on. So it means that we need to find a way to process the signal, and the only way to process the signal is approximate that signal with number of signals, but in a technical way. We will not be doing it randomly, we will be doing it with a pure logic. Okay. So, and this brings us to a concept which is called Fourier analysis. Fourier analysis is, here I said rainbow effect. So if you have light, it is coming in, and then you can see that there are many light dispersing. So it means that one light signal has several frequencies, several colors. So we want to do the same thing. So this is followed from the same concept which we have studied previously. So here we wanted to find R naught, and we came to know that the equation for R naught is this F1, F2. Right?
In real life, when you're dealing with the signals, when you're dealing with electrical signal, electronic signal, is it going to the same formulas or?
Yes, so this Fourier series, you will see that it can represent any signal, whatever field it is. It is electrical, or it is sound, or whatever signal, you can represent it with the Fourier series. So this is actually a big feature of Fourier series. And you will see later on that any signal you take it, you can convert it into Fourier series. Okay, so it means that here we can do similar things. So if you have multiple functions, we can do the same R naught, right? So it means that here you can see that you have R2, R3, and so on. So if I go back, so R naught was somehow F1, F2 integration divided by F2 square integration. Somehow this was a function for R naught, right? So the same thing I can do for if Rn, so I can select, if for example this was R3, so it would be F1 times F3 divided by F3 square, and so on. So it means that we need to repeat that single formula for all the functions to find each constant. So previously it was 1, so in order to find more, we need to repeat the same formula. And there is an added advantage that if those two functions, so one is the actual function and one is the approximated function, if these two functions are somehow orthogonal to each other, then it brings us very easy calculation. We'll reckon later on. What does orthogonal mean? Orthogonal means, if for example this is function f1, so function f2 is at 90 degrees. So it means that, how do we define orthogonal? Anything which is perpendicular to each other, we say that this marker and these two markers are orthogonal to each other. It means that they are perpendicular to each other. Right. And here we say that if these two functions using which we are doing the approximations, if they are somehow orthogonal to each other, this makes our problem more easy. And what is the best example for orthogonal signals? Cos theta and sin theta. Because if, for example, you say cos theta is here, sin theta is here, or in sin theta is here, or in other words, we can say that if I roughly draw the curve for sine, so at t equals to 0, sine 0 is 0. However, at t equal to 0, cos 0 equals to 1. That means that curves start from here. So it means that they are actually away from each other by an angle of 90 degrees. So it means that this difference is pi by 2, which is 90 degrees. So we say that if, for example, these two signals are orthogonal, then our problem becomes more easy, and then we can simply find the coefficient again using the same formula, and we can iterate it with the n's. For example, n equals to 1, 2, 3, however number of functions we have, we can iterate with those functions. So now this is bridge to Fourier series. So this brings us to Fourier series analysis, and we'll see later on that Fourier series says that any signal can be represented using sines and cosines. So if you have a signal, you can represent it by combination of multiple sines and cosines. Here we're going to study two types of Fourier series. One is called trigonometric Fourier series, and second is called exponential Fourier series. Trigonometric Fourier series means trigonometry, sine and cosine. So it means that here we will be representing a signal with sine and cosine. We will start with the equations and so on, and then we will try to go through different examples that how we going to represent a signal. So without wasting time, let's move on, and you will find it easy. Of course, in terms of calculation, it's rigorous and hard, but in understanding, you will find it easy. So here it is said that a complex periodic waveform can be analyzed into or synthesized from a number of harmonically related orthogonal sinusoidal signals. So it means that if we have a periodic waveform, so here the main focus is on a periodic waveform. It means that Fourier series can only represent periodic signal. Later on, we will see that if you have aperiodic signal, you know the difference between periodic and aperiodic, right? Non-periodic, it doesn't repeat. So later on, we will see that for an aperiodic signal, we will going to use Fourier transform, which will come later. But whenever you will hear Fourier series, this is only for periodic signal. It doesn't hold for aperiodic. Okay. So it means that if you have a periodic waveform, we can represent it with number of sinusoids. How are we going to do that? So imagine that you have a signal f of t, and you have to write it in terms of Fourier series. So Fourier series says that a signal f of t can be written in this form. And what is this form? This form is a naught, which is a DC value, then an cosine n omega t plus bn sine n omega t. So it means that we can write this equation with the sum of sines and cosines. But here the main thing is that we need a naught, we need an, and we need bn. And once we have this, we can, and here you can see that n equals to 1 up to infinite. It means that we can choose, previously we were using only one function, which was, for example, f of 2. Here you can use infinite functions to represent a signal. Infinite mean normally we take, for example, up to 10, up to 20, and the more function we take, it means the approximation is even better. But as I said that our main function by approximation, what we need, we want to analyze a signal. So if, for example, you have a signal f of t, you want to break it down into number of components. So our main objective is to see that if, for example, you have a signal, what are different frequency components in this signal? Okay. So it means that if you are given any f of t, you can say that f of t, if it is periodic, you can write it in this form, a naught plus an cosine, bn sine. where omega we all know that it's 2 pi f, 2 pi by t, where t is the time period. Now the critical thing here is to find a naught, a and b n. A naught is very simple. Like here I said it's a DC value. DC value is normally referred to as average or mean value. So, okay. So, in the previous slide I said that we will be using this equation multiple times and somehow try to find different values. So the same concept is here. So as I said that we need to find A naught. Previously we need to find, we were supposed to find R naught, A n and B n. So here if we talk about A naught, so A naught is mean of the function. So whatever your function is, you have to take mean of that function. So you can see that okay, so it's mean that here you can see that we need to find A naught. So A naught is mean of the function. So whatever function you have, if you have function f of t, you will take that function and you have to integrate it between. So previously I said that it is for a periodic signal. It means that it has some time period. But here you can see that I have put it as 2 pi. Why I have put it as 2 pi? Because you can see that here we have cosine, here we have sine. So for normally for sine and cosine, the period is 2 pi, which is very trivial thing that they repeat after 2 pi. So if I put it here, so this point is pi and this point is 2 pi. And this axis is omega t axis. So it means that for a sine and cosine, the period is 2 pi. So that's why since these equations involve cosine, yes.
So can you draw that with blue ink? I can't see it properly.
So your axis is omega t axis, which is the angle axis, and if I write equation, it would be sine of omega t. It means that if I start from 0, if I put omega t equal to 0, sine is 0, sine 0 equals to 0. If I put omega t equals to pi by 2, sine pi by 2 equals to 1. If I put sine pi is 0. Similarly, sine, this point is 3 pi by 2, 3 pi by 2, this is minus 1. And similarly, sine 2 pi is 0. So it means that it starts with 0, it go until 2 pi and then it repeat itself. So it means that the period for sine wave is 2 pi. So that's why in these equations, normally for average, we know that if you want to find average, we say that time 0 to t, x of t and dt. But here, since we have sines and cosines involved, so that's why we will limit our time period as 2 pi. So that's why we have written 1 by 2 pi minus pi to pi, or we can say that 0 to 2 pi. Either way is fine. You will see your function and then you can decide whether you need to take limit from pi to minus pi to pi or 0 to 2 pi. Both is fine. Why? Because the signal is periodic, f of theta. This was simple, very simple, because it was simple mean. However, A naught is slightly different. You have to take the function, you have to multiply it with cosine of n theta, and since I said that this omega t is replaced with theta for easy integration. Why? Because since I am considering time period
It's
2 pi, sorry.
2 bar, okay.
Yeah, so the time period is considered as 2 pi, so it means that I am taking 0, 2 pi, pi, 2 pi, and this x is omega t. So consider this omega t as x. So it means that now your integration would be with respect to x. So in order to avoid confusion writing omega t, it has been replaced with theta so as to have a single number. So theta, theta, similarly you have cos n theta, and here you have sin n theta. So it means that in an you will multiply the function with cosine, in bn you will multiply the function with sine, and you have to integrate it between minus pi to pi or 0 to 2 pi. So whenever you are given a function, the very first step you're going to do is to find a naught, an, and bn, and which you will see now. Okay, and once you have find a naught, a and bn, normally it is a better way to draw its spectrum. This is called spectrum. So what does spectrum mean? It means that how you going to draw, you have a naught, you have a1, a2 and a3. A naught we know it is at 0 point, and where this is n of omega, the axis is with respect to n. So n0 you have a naught, n1 you have a1 and b1. Similarly, at 2 you have a2, b2. And their side you can see that here it is on positive and here it is at negative. It will strictly depend on your outcomes. For some case you will see that a1 is 0, b2 exists. For some case you will see this is positive, this is negative. So this is just a random diagram. But once you will find a1, a2, a3, all the values, you can draw it in terms of line spectrum. This is called line spectrum for Fourier series. And this spectrum actually tells you that how much frequencies or what are different components that you have in your signal. So let's start with an example which will give you a good idea of what we have just seen. So we will find Fourier series for some typical signals, and you know in the first lecture we went through all these signals. This is called square wave. So this is your square wave. We start from 0, go to positive side, then go to negative side, and then repeats from 2 pi. What is time period here? What is time period for the signal? Who will tell me what is time period? 2 pi. So, yeah, speak. Yes. So, it's 2 pi. How we define time period? After which waveform repeats itself, right? So, it's 2 pi. So, one thing is clear, that time period is 2 pi. Now, the second thing is we need a function. So, it is highly possible that you are not given with this function. You are only given with a waveform, and you need to write this function from the waveform. So here is, you know that your a naught, a and bn all will be integrated for a period of 2 pi. So you have to write this function from this point to this point. You will need to see that what is your function. So here you can see that your function has two values. You have one value from 0 to pi, and then from pi to 2 pi you have a different value, right? So that's why I can write it as f of omega t is v from 0 to pi, true? What is value from 0 to pi? V. And what is value from pi to 2 pi? This is your function, and you now need to write its mathematical form.
Minus v.
So from pi to 2 pi the value is minus v. So it means that now we have our function, it has value v from 0 to pi, and it has value minus v from pi to 2 pi, right? And since, as I said previously, that for the sake of simplicity, we have replaced this omega t with theta. It will not affect your calculation because your variable is completely omega t. So simply replace omega t with theta so that you don't do mistakes while you do calculation. Because sometimes you will see, okay, sine of omega t, you will write it as cos of omega t divided by omega, which is not true. Why? Because your integration is with respect to omega t. The whole omega t is your function. So that's why we replace, in the second step, we replace it with theta. So it means that now we have function f of theta. Who will calculate the a naught? What is a naught? A naught is the mean value, right? It means that a naught equals to 1 by 2 pi 0 to 2 pi f of theta d theta. Who will tell me without calculation that what is average value for this waveform?
Zero.
Zero.
0, right? Why? Because it has equal positive and equal negative cycles. And mean or average is just adding all these values. So adding this with this will give us 0. So it means that if you have a signal which is symmetric about y-axis, this signal is called odd signal. Odd signals are symmetric around y-axis. So it means that if you have a signal, this is symmetric about y-axis, you can see, right? And this is also have symmetric plus bipolar. This is symmetric about y-axis and it has two polarities, right? Equal positive, equal negative. Mean it has equal positive side, equal negative side. So that's why this such function is called odd function. And for odd function, you don't have a naught. A naught is 0 indirectly. Even if you calculate it, you will see now that even if we calculate it, so you can see here is. Do you want me to solve it or it's okay from the slides?
Can you solve it, please?
You want me to solve it? Okay.
Because I think it's left. Because a few steps has been missed.
Okay, so A naught is 1 by 2 pi, 0 to 2 pi, f of theta d theta, right?
Yeah.
It's the very first step is 1 by 2 pi is outside. Now inside we need to break the integration. So the integration is from 0 to pi and then from pi to 2 pi. Right?
Yep.
Let's mean that. What would be value here? What is the value for function between this period?
It is.
What I'm going to put here and what I'm going to put here?
And this will be f omega t.
A knots, right? A.
No, this is your A naught, right?
So
I'm going to
it's gonna be zero.
So from this to this is V,
V and minus V.
and from this to this is minus V,
Yeah, okay.
right? So this was the first step. The next step is take everything out which is not function of the variable theta. So it means that we can take V out. So A naught is V divided by 2 pi,
That's a constant.
0 to pi, this is 1 d theta plus, oh no, this minus will come here, minus pi to 2 pi,
V.
this is 1 d theta, right? I have taken V out because V was a constant number, right?
Yeah, that's right.
What is integration for 1
Just theta.
theta? Very good. So, it means that V divided by 2 pi, so this is theta from 0 to pi minus theta from pi to 2 pi. This is true, right?
Yep.
Both are 1, so integration of 1 is theta for both cases and both have different limits.
Then you gotta apply the limits.
And now we're going to apply the limits. So V by 2 pi is outside. Inside it will be pi minus 0. It means that upper limit minus lower limit. So upper limit is pi, lower limit is 0. Similarly,
2 by minus 2.
so 2 pi minus pi. So it's V by 2 pi. Here you have pi, then you have minus, then 2 pi minus pi pi. So you can see that
It will be 1.
is equal to 0,
Zero.
right?
Yeah.
That means that the average value for a odd signal is 0, and which is also we have seen from by calculating a naught. And even if you can look at the waveform, you can tell that a naught is 0. Okay, right. And the same thing. Right. So now the next part is to find
The A naught.
A naught.
And I have to use the formula that you showed.
Okay. So okay, so it means that now we have to find A naught, right? Sorry, AN. AN is 1 by pi. So you have to be clear that for A naught here it's 2 pi, but for AN here it's 1 by pi. This thing is same, minus pi
1 pi.
2 pi, but in this case, as I said that you can either take minus pi to pi, or you can take from 0 to 2 pi, whichever is feasible. And we have seen that in the example we were doing, it was obvious that if we take 0 to 2 pi, this is more easy than taking the, although signal is here as well, because this is the periodic signal, you have phase signal on this side, but it depends on, even if you take minus pi to pi, still you will get the same answers. Okay, so here we're going to take 0 to 2 pi f of theta cos of n theta d theta. So this is the main equation. Now what we need to do, we need to break the integration into two parts, because we have function into two parts. So n is 1 by pi, inside it would be 0 to pi cos of n theta d theta plus pi to 2 pi cos of n theta d theta, right? So it means that I've just written the formula. Now I'm going to put the value of function, and we know that the value of function f of theta is v and minus v, 0 to pi and pi to 2 pi, right? This we already know from the first step. So here we can put v, and here we can put
Minus 0.
minus v. This is again not difficult. So we just need to take v outside. So a naught is v by pi, 0 to 2 pi cos of n theta d theta minus pi to 2 pi so for good, right? That means that we have taken v out. Now the next step is that we need to find integration of cosine, and we know that the integration of cosine, what is integration of cosine?
Sine theta.
So it's sine theta, and then you again need to take derivative and divide it. So here it's n theta, right? So n will come in
Well,
between,
divided by any absolute means.
right? Okay. So it means that if I write it here, so it's v by pi, so it would be sine n theta by, sorry, here n. This is 0 to
2
0
pi.
0 to pi. 0 to pi minus sine of n theta by n, 0 to, so pi to 2 pi. Good? So far it's fine, right? Okay. Now the next step is take n outside. So it will be v by n pi, inside it will be sine n theta 0 to pi minus sine n theta pi to 2 pi.
Just apply the limits for it.
Now we need to apply the limits, right? Okay. So it means that it's v divided by n pi sine pi minus sine 0. Upper limit minus lower limit, right? So the sine n pi and sine 0, n times 0 is 0. Then there is a minus, and inside it would be sine n 2 pi minus sine n pi. Any problem with applying limits? So just upper limit which was 2 pi, and lower limit which was pi, and we have n as well.
It's gonna be minus.
Okay, so now after applying limits, once we have in this form, we always look for, because we know some typical values for the sign, so we need to look for the values. So we know that we know something that sine pi is 0, sine 0 is 0, sine 2 pi is 0. So it means that if you have 1, 2, 3, 4, 5, whatever is value of n, sine is 0. The only point where sine is 1 is pi by 2. But here we will never get pi by 2. Why? Because n is 1, 2, it's integer number 1, 2, 3, 4. So it means that this sign, this is already 0. This will be 0 for all values. This is also 0, and this is also 0. So it means that your an is 0. So this brings us to conclusion that whenever you have whenever you have an odd function, you will not be getting a naught and an.
In the exam, you have to show the 0, y, right?
Yes.
That's,
Yes.
you can't just
So it means that, understood, right? So sine is only have value when you have multiple of pi by 2. But if it is multiple of pi or 2 pi, then it is always 0. Cos has value also.
So you know the n, are we assuming that it's an integer?
It's an integer, yes. It's 1, 2, 3. And even if you have a look on the this spectrum, you can see that we have 1, 2, 3, 4. Yes, this is integer. Okay, so it means that we have calculated the an, we have also calculated the
Bn.
b. Now we have to calculate bn, right? And you will going to do it. So start calculating. The only difference is that instead of integration of sine, cosine, you have to take integration of sine, which is minus cosine and theta by n. Start doing it. There is no difference except a single integration. You have
For bn.
5 minutes to do it.
Oh. It's instead of opposite side. Everything is the same.
you show the formula. Yeah.
So the formula is Bn equals to 1 by pi 0 to 2 pi f of theta sine of n theta d theta. So this is your formula. Then you need to break the integration, right? So this would be 1 by pi. Inside it would be 0 to pi v sine of n theta d theta minus pi 2 pi minus v sine of n theta d theta. And integration of sine n theta d theta is equals to minus cosine of n theta.
think it's gonna be -1. Answer.
So this is minus cosine of n pi. This will become 1, cos 0 is 1.
Yeah.
Yes. So this is plus 1 and this will be cos of n 2 pi minus cos of n pi.
Yeah, but this is gonna be cos.
And we know that if, again, now you have this form of equation, so you need to look for n. But one thing is that, so for we normally identify each and every term. So I want to show you this term, which is cos of n 2 pi. So I know that cos of 2 pi is 1.
Is it 4b by 5?
Sorry,
Answer.
4b by pi. Yes, no problem. Yes. So cos 2 pi is 1, right? If I put n equals to 1, this is again 1. If I put n equals to 2, this is 4 pi, which is again 1. If I put n equals to 3, again 6 pi, which is 1. That means that this is for all values, this is 1. Normally, whenever you will get this equation finally, you need to check your equation for two ends, odd and even. You will see probably sometimes they have different values. So we will see this equation now. So if we want to see, so it means that we have this v by pi n, and this is 1, and this is minus and minus, this is minus 2 cosine n pi. This is our final equation, right? Because this went to 1, this is 1 here, and minus, both are same, so minus 2 cosine. So this is your final equation. Now we need to look at this equation for both ends. Now we need to look at this equation for both ends. So it means that Bn, if we take odd 1, 3, 5. So let's see what happens there. So it means that if we put, this is cos n pi. So if we put, for example, 1, this is cos pi. If you put 3, this is cos 3 pi. If you put 5, this is cos 5 pi. And we know that cos pi is minus 1, minus 1, minus 1. So it means that if you have odd values of n, then this term is minus.
Minus, yeah. So it's gonna be 1 minus.
So here it did. So this was also 1. So I'm sorry, here it's 2. Because this was also 1 which I missed. So this is 2 minus 2 cosine of n theta. Or if I further simplify it, it would be 2. I can take outside pi and 1 minus cosine of n pi. So it means that for n odd, I can write this equation as n odd. So this, after writing this equation, these are the steps you can follow. So n odd, so I know n odd cos of n pi is equals to minus 7. So it means that for odd n, cos pi is minus 1. So I can write Bn equals to 2b by n pi. Inside it will be 1 minus minus 1. So it would be, this term would be 2. So it would be 4b by n pi. So it means that your Bn has value 4v by n pi, which I guess was close, and this is your Bn. However, if you want, the next step is to find for even. So it means that now we have to take n even. So for n even, so cos n pi. So if I take 2 pi, 4 pi, 6 pi, so all of them are 1.
What is it?
So it means that for even we have Bn for even equals to 2v by n pi inside 1 minus cos of n pi is 1 for even. So this will become 0. So it means that it has Bn values only for.
So where did the 2 come from? In the
The
branch?
yeah.
No,
Here.
not here. Other one.
Like
When you're doing
1
Bn
minus 1.
equals for odd.
This.
Yeah.
Yeah.
No, there is no denominator. I was just saying that these two combine as 2. And finally, you will see that you have Bn 0. So it means that for this specific waveform for square wave, you only have value for Bn for odd ends, right? If for even n, Bn is 0, your a0 is 0, your an is 0. So it means that we have found our Bn. So once we have found this, now we are in a good position to write the final equation for Fourier series, because we needed a0, an, and bn. So a0 would be 0, an would be 0. The only thing would be left bn, and bn would be left for n odd. Any question on this?
More examples. Example 2 is make this as the tutorial site. This is the tutorial. Example 3. Not bad. Let's see. This one.
Okay, so it means that now we have Bn and we have found everything. So it means that we are in a good position to write the final equation. So it means that now the Fourier series we already know it. An, a0, an cos of n omega t, bn sin of n omega t. We know from our calculation a0 is 0, n is 0, right? So it means that we are only left with bn sin of omega t. And out of Bn, again we know that our values only exist for odd n. So it means that for only odd n, this term, which is our Bn, has value of 4v by n pi. And this sign comes from here, right? So it means that here you can write n equals to odd, or even if you don't write, sometimes you could write odd. So it means that you know that this n exists only for odd. Now you can write this equation, you can expand it. Now you have a general equation, so you can put n equals to 1, so you will be having 4v by pi sine of omega t. When you put n equals to 3, so here it would be 3, 4v by 3 pi, and here it would be 3, then 5. So it means that now you can represent this signal with infinite signs, and later on you will see that it somehow will show the actual signal. Okay, and if we draw the spectrum, you can see that at 0 you have no value, then at 1 you can find the value. If for example this spectrum has been drawn by taking v equals to 10, so normally for example I will ask you to draw spectrum, you will have this as a number or not, I will tell you. So if you put v is 10, so you need to take this only. So if you know this is 10, so this would turn out as 12.7. This term would turn out as 4.2 and so on. So it means that we only take coefficients to draw the line spectrum. And there was another conclusion that the series contains only odd harmonics, odd sign terms. So it means that there are no other terms, no Bn for even, Bn is only for odd. And I tried to plot this function. So I have taken the same function. This is the same function. For simplicity, I just put this as, this whole term is 1, this whole term is 1. For simplicity, just to plot and see whether it is equivalent. And similarly, omega, I have taken it as 1. So you can see that this is 1 by 3 sine of 3t. So here omega is 1, here omega is 1. And what we have taken, we taken square wave, right? It was a square wave. And when I plotted this signal with 9 terms, so you can see that it is more or less giving us a square wave. But you can see that square wave was straight. Here you can see a sign. Because we have approximated it with less number of signals. If we take more signals, you will see that it would be a straight signal. But now we came to know that we have a square wave, and inside square wave we have omega frequency, we have 3 omega frequency, we have 5 omega frequency, and so on. And if I somehow relate it with power systems, those who are from power systems, they will somehow know that in power system, for example, in AC, we have this frequency omega equals to 2 pi f, and f is normally 50 hertz. Normally we do have UPS, or we do have solar, so from solar we convert DC into AC. So ideally we want that a solar convert a DC into AC which has only one frequency, that is 50 hertz. But this is not possible. Why not possible? Because when we take a DC and we convert it into AC, so sometimes this is distorted. So this is not pure AC. So in order to analyze this signal, we break it to Fourier series. So if this was a pure AC, then you will see all other terms would be 0. Only you have omega term, which is 50 hertz term. But if it is not pure AC, you will see that will be having an omega term and so many other things. And all other things are called harmonics, unwanted signals. So for power system, Fourier series is very useful, that you analyze a signal for power quality, whether this signal is good or not, whether what frequency it has, and whether this signal is good for certain equipment or not. So from this, we say that if we have a look on square wave, this is very basic type of DC to AC conversion. So imagine that this is your DC and you are converting it into AC. Although normally AC is like this, right? But if we take a very simple conversion, we take positive and negative. So once we take this, then we see, oh, we have so many unwanted signals in this. And how are we going to know that? We're going to know that from Fourier. So that's why it's very important to break signals into frequencies, so that we know that how to design. If, for example, we have these, for example, I have omega, which is for a middle component, then I have this. If I don't want this component, then I have to design a filter. But to design a filter, first I have to know that what are different components in my signal. So if I want only this one, but I don't know whether I have 3, whether I have 2, so first I need to know what signals I have, then I design filter accordingly to filter those out. So that's why it is very useful to process the signal, and for that Fourier series is the best. I also put a short code here. We'll see it in.
I have a question. You know the first harmonic, first one, second one. Go back to the.
Sorry, yeah.
You said the first harmonic is 12.7. In the formula, which one is the first harmonic? Is it going to be the
First harmonics is this one, right? This is your
first? That's the first one.
A1. Sorry, this is your B1. This is your B2.
And this is B3.
And this is your B3, which comes from actually this B, right? Or you can use this equation, or you can simply put your B's here and then you plot this. And you can see you don't have even harmonics here. And this green is only B1. There is no A1, and there is no A0. There is no A1 and A0. This is only B1. So it means that only all harmonics. Any question on this? So this is the physical interpretation of Fourier series, that how we're going to use it. There is another example which is called sawtooth waveform. So we are given a sawtooth waveform, and we have been asked to find the Fourier series. What would be the very first step? The very first step would be writing a function, because we don't know function at the moment. So it means that this is our waveform and we need to write a function. As I said previously, that you can take 0 to 2 pi, or you can take minus pi to pi. The problem here in taking 0 to 2 pi would be, you can see that I don't know, for previous case it was a straight line, so I did in v, but here I don't know the function for this. Similarly for this. So it means that if I am taking 0 to 2 pi, I have to write function for this somehow, I have to write function for this somehow, which would make life difficult. However, if I take minus pi to pi, this is one single line, so I have to write only one function. So it's up to you how you're going to take the limit. So, but overall the period should be 2 pi. You can start from here and go on, but overall the period should be 2 pi. So it means that now here the very first step is to write the function. Here we are not splitting it into two parts. Why? Because this is only one function which is going like a linear straight line. In the previous case it was positive and then it was negative. How we normally write a function? Who will explain to me that if you have a waveform, how you write a mathematical function out of it?
Do you normally take points?
Have you studied this, right? I'm sure y equals to mx plus c.
Oh yeah, you just take 2 points, find the gradient.
Yeah, exactly. So whenever you have a graph, a line graph, so what you normally do, you normally take some points, then you find the slope or gradient, and then you put in this one. So if I see there is another equation, y minus y1 equals to m into x minus x1, but the very first step is to find slope, which is m. So it means that we have to find slope for this line. In order to find slope, what are the formulas? Formula is
It's the change in y over change in x.
x2 minus x1,
Over x.
y2 minus y1. We can take 2 points. One point is here, which is minus pi minus v, because here x is minus pi and y is minus v. And this point we can take, this is
So y.
pi and v, right? So these are the 2 points. Any confusion on this?
Which one did you take as x?
So you know the.
So one point is here
Yeah.
and one point is here.
So how do we account for the vertical lines? You know the vertical.
So no, this vertical line is just showing a repetition. This is, I mean, at this point, this signal is going to 0. So no, we don't account for these vertical lines.
Okay.
Yeah. So we say that at this point we have this value. However, again we have a repetition. So this is another domain for the mathematics where we account, but here we don't. So this is just.
This is 0, yeah?
Point, yes.
Okay.
So at this minus pi point, you have this specific value. So we have 1 point this, right? So we say that at minus pi, this function has this value. So at minus pi, the function has minus v value, and at this pi, the function has v value. So these are the 2 points that we're going to take for the gradient. So it means that if I take this as x1, y1, and this is x2, y2. So x2 is pi and this is
No,
minus
y on top
pi,
and
and
x.
similarly
You did x on top.
v2 is v and minus v. So no, this is I written other way around. Sorry.
So isn't it like the like dy
Also,
dx?
that's why-
The way I remember it is dy dx, so change in y change in
Yes,
x.
y2
Yeah.
minus y1 divided by x2 minus x1. Sorry, yes. So v minus v divided by pi minus pi. So it would be v by pi. So the gradient here is v by pi. This was the first step. And the second step is that we can choose any, now we can use this equation. To use this equation, we can choose any point on this function and use this equation. So for example, I choose this point, which is 0, 0. So I can put it here. So y minus 0 equals to v by pi x minus 0. So it would be y equals to v by pi x. And here x is omega t, right? So that's why our function is v by pi omega t from minus pi to pi. And since we said that for the purpose of integration, we replace omega t with theta. So that's why you can see that we written v by pi theta minus pi to pi. So this is how if we are given with a graph and no function, then this is how we usually find a function. And if somehow, because if for example I haven't selected the second point as this, and if I have selected the other point, your function would be slightly different, but maybe you will find a slight difficulty in integration, but the end result would be the same. Why? Because it is periodic. Now, this function is odd. Why? Because this is symmetric on the y-axis. You can see that this and go like this. So it means that anything which is symmetric around the y-axis is an odd function. And for an odd function, we know that we don't have an. So an is 0.
Is A0 also?
And a is also why? Because it has equal positive and equal negative portion. So a naught is decided based on the how much portion, if they have equal portion, positive or negative. Whereas symmetry, sometimes you will see that they have odd symmetry, but they are little bit shifted. So you will
Is
be
this
having
all assuming that the function is periodic?
assuming the function is periodic, yes.
Okay.
Because Fourier series is always for periodic signal. For aperiodic, there is no Fourier series.
Okay.
We'll see later, yes. Okay, so if somehow we still wanted to find the a naught, so you can see that we have 1 by 2 pi, 0 to pi function value, which is typical equation for a naught. Then if you put Vm by pi minus pi to pi, so V by pi is constant, so we can take it out. So it would be V divided by 2 pi square, and inside theta would remain, right? Then finally, if you want to take integration of theta, what would be integration of theta? Integration, no, not derivative. Integration of theta,
So
like integration of x is
Well, theta squared over
x square
2.
by 2. So it would be theta square by 2. So it would be theta square divided by 2. I don't know where I put 2, but yeah, 2 should come outside. So there is another 2 here. Yeah, since I knew the answer is 0, so okay. So finally you have theta squared. You can put upper limit minus lower limit. So pi squared. Then in the lower limit is minus pi. So square will make it positive. So this will come out as 0. So it means that for an odd signal, the value of a naught is 0, and we also know that the value for n would also be 0. We can calculate it, and you will see that it's 0. Okay, so the tricky part here is to find Bn, or it was also to find an, but we know that n is
0.
So let's solve it. Okay, so you have Bn. What is formula for Bn? 1 by
1 over pi.
pi
2 pi.
minus pi or 0
Oh,
to
yeah.
pi. Okay, and
F theta.
f of theta
Sine and theta.
sine and theta d theta. Good. Now we can put function, which would be 1 by pi. What is the value for function? V by pi theta, right? Yes, function value is V by pi theta. So again, very first step is to take constants out.
Versus B upon Y.
So it would be V divided by pi square, and inside it would be minus pi to pi theta and theta d theta. And we know here we need to apply integration by parts. Again, integration by parts, as I said, is u, the first function, then integration of second function, minus, you need to put integral sign, take derivative of first, and then the integration of second. This is how we apply
So
the integration.
we're picking the simpler function, right?
Yes, so the first function, we will always pick the simpler one. Why? Because end of the day, you again have to take derivative here.
You have to make them two terms now. Times 1 and times 2.
Yeah, so u is your first term, so
Yeah.
it means that here, which one I should select as the first term?
Theta.
Theta.
Yeah.
Why? Because we know that the derivative of theta with respect to theta would be 1. And if we don't select the first one, and if you select the second one, then you will see that you will be having another integration by part on this side. Then you will be having, because, and then it would be an infinite loop, and yeah. So imagine that you have selected sine theta as first function. So you have sine theta, then here when you will take derivative of sine theta, it will be cos theta. You will take integration of theta, it would be theta squared. So here would be another integration by part, and it will make your life difficult. So that's why it is very important to take first function as a simpler function. So
So, formula.
b by pi square. So first function, right? What is integration for sine theta?
Minus cos and
Minus cos.
wait, sin and theta, right?
Minus
Yes.
cos
Yeah,
and
minus cos and theta over n.
on-
Alpha and
N, right? So this was
yeah.
this was the first thing. Then we move forward, put a minus. Then we know that here we need to put u prime, and we know that u is theta,
So it's just 1.
so u prime would be 1. So here is 1, and here is another integration which is sine n theta,
Over n.
okay, d theta. And what are limits? Here we have limit minus pi to pi, we have limit minus pi to pi, and minus pi to pi. So it means that now, since we have already taken derivative, we can solve it, which was same as this one.
Then you have to take an outside, I think. This is gonna be the.
Yes, we will take n outside, yes. But since we have at the moment, there will be another n coming here, so we'll wait for a while. So it's b by pi square. So it's minus theta cosine of n theta by n, limit minus pi to pi, and here it would be, for this it would be minus cosine n theta by n d. You can see we have another integration still in place, right? Because we have two integrations. Finally, we have b by pi square inside. I'm still writing it as divided by n, limit minus pi to pi. Here we have 1 by n from this, and now we again, so I will take minus minus as plus, and I again need to take integration of cosine, which is sine theta. It would be turned out as sine n theta divided by n, so I will put n squared here. And you have limit minus pi to pi. So now we need to apply limits, right? From here I can somehow guess that since we have upper limit pi, lower limit pi, so sine never stay for pi, right? So this term, even if you put upper or lower limit, this would turn out as 0. Because sine pi, sine 2 pi, 1 pi, 3 pi, sine minus pi, anything is 0. The only thing that would be left is this part.
But this one will be
Sorry?
first term.
So we need to apply limits on this part now.
I will say
So it would be V divided by, I can take n outside, n pi square, and there is a minus sign I am taking outside just for the sake of applying limits. So pi cos of n pi, and then there is a minus sign, and then you have minus pi cos of minus n pi, right? So you have upper limit, pi comes here, then you have lower limit, minus pi comes here, and minus pi comes inside. So it would be minus v divided by pi square. So if you have minus inside cos, we'll normally say that cos eats minus sign. So even if it is cos minus pi, or if it is cos pi equals to 1, indirectly we say that cos of minus theta is equals to cos of theta. So this minus doesn't impact inside. So, but this minus will get plus here, so pi cos of n pi plus pi cos of n pi, since minus doesn't affect cos. For sine, this is not true. So end of the day, these two pi n pi minus pi square.
How many examples left? So we did 12 examples.
Yeah, we'll do that in tutorial class. So if we somehow solve the Bn, I will Bn this.
It's alright. It's not too bad.
If we can quickly solve Bn and then find, similar to the previous case, we can put B1, n equals to 1, 2, 3, 4, 5. And from here we came to know that we have values for 1, 2, 3 is negative, and for 2, 4 cosine is positive. So we end up with this equation, this is your final equation. I just wanted to show you this curve. So same as I done previously, I just put everything as 1, omega 1, and I draw the waveform with the approximated signal. So you can see that we were having a sawtooth, now the approximated one is close to sawtooth. It has some variation. Why? Because it has been represented by less number of signals. And at the same time, you can see that if you plot these values, so as I said, for odd it was positive, for even it was negative, positive, negative.
One question, you know that this you know the graph you showed previously, is it gonna be considered as pseudo? Be like that, because this is
No, this is no, because this is approximated with some function. So this is approximation, means this is not close to sawtooth. So if you take more numbers, for example, if you take up to 20, you will see that it will turn out as a
I
sawtooth.
remember I was doing one of the previous other lectures. I had we had keep getting this distortion with the photos. The teacher
Feature if I
refused
need one.
So probably it was distorted or something.
we were doing on the source code anyway, it wasn't calculation. It was
Okay.
practical.
So today we have a tutorial session. So
Yeah.
Some put headphones in deafness. Yeah, receive a headphone per with this in the system. And don't even put